welcome back to our Python class, and today we will take a look at one of the largest Python data analysis libraries, Pandas. Right, so we'll talk about how it works. Again, we'll be using Google Colab here. Again, since it's the cloud-based version, you can of course run these notebooks at your own Jupyter installation, whether it's through Anaconda, right? And also you could run this code also through a regular Python program if you want. Again, so here's the link from my repository, and I'll connect to this Google Colab, create a virtual machine, and let's see what kind of machine we get. Probably nothing special. Probably we have just regular 12 gigabytes of RAM, 100 gigabytes of hard drive space. Okay, so what is Pandas? So Pandas is the premier data analysis library, or in other words, Excel on steroids, right? So if you know how to use Excel, well, you pretty much are in good territory already. Also, if you know how to use some databases, something tabular data, if you ever worked with the tabular data, you should be able to get a pretty good idea what Pandas can do. Of course, Pandas is so big that it's not impossible to, you probably need like 2 courses, maybe many months of courses to explore everything that Pandas can offer. Right, but here are some good starting points. So we have our home page, right? This is the home page, has good documentation, right? And so again, Pandas is included in the Google Colab, also included in through your Anaconda installation on your local machine. Otherwise, you have to install it using either pip install or conda install. So okay, on this is a book by the creator, Wes McKinney. He used to be, I think, still a financial analyst in New York, and but since then this project has grown in the last 12-13 years to become really big. You can see even Mark Zuckerberg's wife is supporting, some other big companies are supporting this project. So very important if you ever work with Python and with tabular data. Okay, and there's some nice documentation, right? And there's also a nice cheat sheet. It's in our course materials, right? Data wrangling Pandas again. So we will be working with tabular data, right? So idea, you have rows and you have columns with some specific data type, right? So let's look at some of the ideas. So first of all, of course, we need to install our code needs to use it, right? So we're going to import Pandas. Okay, this is my notebook, and we are going to import NumPy just in case, and matplotlib also just in case you want to plot something, right? So we can do commands in Jupyter. Remember, we can use to run terminal commands. Remember that, right? So we can check what our directory is, and we have sample data, right? So we can get started with this actually, right? So if you're using Google Colab, here you have a map with sample data, right? And you basically can check what's in there. Oh, we can actually have some CSVs. So California housing, well, let's do train, right? Or test. Well, let's do test, right? Or train. So what we do is, again, so Pandas offers many different ways of reading data. So CSV is probably the most common one. So let's do that. So California. So we need to go to the sample data folder. Right, the folder, right? This only will work for Google Colab because in your own machine you probably don't have this, right? This comes for free with in all Google Colab instances. So housing test, right? CSV, right? So the only thing is CSV. The only problem with CSV, it's a huge format. There's no standard for CSV, so you might there are all kinds of gotchas, but that explains why this method, right, is really huge. If I press Shift Tab, let me press Shift Tab, and let's hopefully Google server is woke enough that it actually wakes. And well, it's not picking up today. The help, right? Okay, there we go. I picked up help, right? Yes, this is a huge method, right? So this is a read CSV, right? Reads a comma separated values into a data frame, right? So there are many options, right? Where you want to read, what kind of header, what kind of delimiter. Very important because CSV sometimes might be a TSV, a tab separated value, maybe a semicolon separated value. Let's see what we have here, right? Let's see if we can do this, right? And let's read it. Okay, looks like it worked out of the out of the box on. So we can see there are rows on columns, and I use the head. So first values by default is 5, right? If we want different, then use say head, 12, etc., etc., right? So this default is 5. We have 5 rows, right? We could also do a random sampling, right? We could do random sampling. Again, I'll make a new code. So df sample, say sample 7, for example, right? And I could do a random sampling. So this is random sampling of, if I run it again, I'll have a different sampling. Yeah, I have a different sampling. Okay, so we can get a good idea what it is, what it looks like. But we'll probably want to do more on this data. And I like to actually, I'll show you how you can read, since you might not have access to this data, how you can read data from a external source, right? So let's move something more interesting. This is also interesting, of course, if you live in California, since most of us are in Latvia. Let's check some Latvian data, right? So again, this is a data frame, right? And we can check shape, right? And we can check what kind of columns this has. Now this has float. So these are floating point columns, and you can also get some data. Describe. You can get data describing. You can see how many. There's 3,000. So there's 3,000 entries. Mean value, of course, mean is kind of pointless for longitude and latitude here. You can see median age. That's good, right? In this area, right? That's kind of good. You can see the rooms, income, right? But some of this data you need some extra explanations. And there's a house value. Apparently there's a house in California for $22,000. I wonder how large it is, right? That's kind of strange, right? And again, this would need there's some interesting, again, these values don't make immediate sense unless you know how they are marked, right? These are categories actually, like median income, right? Or population, again, doesn't mean, this probably means million, but again, you have to look up in the description of this data set, yeah. But again, we'll talk more about this when we read data from a external source, right? But again, we can do a transposition right here. This transposition, basically transpose, right? Also a nice data frame of basic statistics, right? But let me show you how you can we can create a data frame from Python list of dictionaries, right? So what will happen? Their keys will be column names, right? So right, these are some people, and food, potatoes, speed, children, right? And this is a list of dictionaries, right? On, so we know what my data is on, right? And I can create my DF, right, from a list of dictionaries. So if you have your own data, if you convert something like this, my data frame you can read, and you have a nice little data frame, right? You can save it, right? And of course, I could save this data frame, for example, into my DF to say, again, CSV, my data, CSV, and let's do that. In this case, of course, we are here, right? Here it is, right? I could download, since this is a cloud service, right? And I could check that this is, if you check in a folder, you could check with a notepad, right? Yeah. So 1, 2, 3, 4, 1, 2, 3, 4, but we didn't name the index, so there's one missing column name, right? But again, simple, right? Simple way of exporting data, right? So let's continue. Let's see about, again, we could of course describe, right? Notice that it will only describe speed on children, doesn't describe food or name. Why? Because those are objects. So if you want everything, then you can do describe like this, right? So speed, children, or usually O, right? You can actually do O, right? This would be better. Objects. So no numerics, it says Valdis. Potatoes is the most common food, right? Frequency 1, right? So these are for string objects. Okay, right. So we can get some stats. We can save. I showed you that, right? I can get a particular column, right? And I can go, of course, also describe it, right? And so getting some stats, I can also get notice something here. So this gives you so-called Pandas data frame series. This gives you a single column data frame. If you need, so you need double brackets. If you need to use so a single column, you want to have a right. You get all interactive table. There's some extra options, right? So let's see. Do we have Titanic? We can get a Titanic, right? But I wanted to move something to a web page. Let's go quickly, right? This is very similar, right? We have it here. No, we don't, because I don't have Titanic. So, well, I'll go to something different. I'll use the open dataset here. Not here, but here, right? We have some different datasets. So, some open datasets. There's a European dataset portal. You probably know this one. Here, some portals, some data sources, right? So here I'll move this up. Where's my movement up? I'm always I'll just do it here, right? Since I'm used to using a local version. So some data sources, right? So I'll use this will be well, I'll just do text, some text sources, and data sources, open data sources, right? More or less I'll be using so right Europe. Yeah. Can we do this actually here? Yeah, like this. Okay. I'll copy it. I'll format this. Provide some sources, right? And let's check some other sources. So of course there's American one, data.gov, right? Again. Yeah. US, right? And well, oops, not like this. And what else do we have? Yes, so I'll use the Latvian one. There's also Kaggle, but you need to register, which also very good source of right. Need to register. Need to have a Google account, right, or register, right. And finally, we have a Latvian one, right, which is what I'm going to use. Latvian open portal, right. Data.gov.lv, right. They in fact they send the data to Data Europe, so you can get from the Data Europe as well, right? But again, since it's nice to use local data, right? So, okay, so that's our data source, right? Okay, so I need a specific URL, so we can read the data directly from web URL, right? So address, right? Address URL unified. So URL, let's figure out what's our URL like. If I go here, I'll go, this is a city in Latvia, Cēsis, a nice city to visit, right? And they are offering a dataset of tourism data, right? And I will go here, right? So I'll go to this hot. So this will be download, but instead of downloading, I will do right click and copy the address, right? Copy link address, and I will show it here as a URL, right? Okay, so it looks kind of hairy because there's an identifier there, right? But this is, this is normal, right? So how will I read it? Well, so I'll do Cēsis, right? Or tourism, right? Or Latvian tourism, or I'll just do df, right? I'll overwrite it maybe, right? It's very typical to, use df, and I will use the URL. And will this work? What do you think? Will this be good? df, right? And I'll do maybe head, right? See first 5 entries, right? Let's see, what do you think? Well, first 3 entries, right? So we'll see, this is not going to be quite what we want. Yeah, so it worked, but here is the famous last words about CSVs, right? You have a semicolons, right? So what do we do, right? So these columns, they call it a CSV, but it's technically a semicolon separated values, so it's not quite CSV. So what should we do? Well, but solution? Solution is relatively easy. We can do this, and we need to enter some separator value. Separator, you see here, Google also helps us here, right? And I do semicolon, right? Also, I like to use encoding UTF-8 just in case we have some non-English, non-ASCII symbols. So this could be in Spanish, German, Russian, Chinese, or Latvian, of course, right? So we want to support Unicode encoding, which usually, right? So we download using as a separator for values, not the default comma, right? And let's check the first three entries. And that looks much better, right? Again, for those who don't know what these columns are, well, we can rename these, by the way, right? We can rename them, right? And I'll do this here, right? We can, of course, do some description, but let's rename it. Let's rename it first, right? Since you, again, maybe not all of you are speak Latvian, right? So we can do this DF columns, right? And, well, right, so we have a 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We can rename them, so we can do this. DF columns can be equals, right? I'll do something quick, right? So months, right? Foreign group, right? Latvian group, family, pair, right? Or means couple, right? Single, right? Friends, just friends, right? Okay. School children, right? School or pupils, or not students, but school children, right? I'll call it like school children, maybe some better name. Pupils, right? And year, right? Let's see what happens now. DF, and we'll use that head again. Yeah. Okay, so we can read this much nicer, right? So pupils, maybe I'll do it pupils, right? Would be easier, but again, the less you have to write, the easier it is, right? So we have a nice little. So again, let's double check. How large is it? What do you think? How large is it? So shape, I like to check shape first. 72. So it looks like it's how many? So let's see what is the year it starts. Looks like 14, but let's check. So DF year mean, right? And 214. Okay. How about DF year max, right? We can do this, and of course, so this year, this dot syntax works with column names that are single word and do not conflict with the data frame methods, right? So that's one thing I should mention. Right? It's very convenient, but there's a school of theory that you should use the full syntax. So for example, Latvian group, right? Let's check Latvian group. I would like to check this, but or foreign group, right? Let's see foreign group. Check DF. So I can't do this. Foreign, it won't work, right? Foreign will not work. So I have to use the full syntax. Foreign group, and unfortunately I have to know the exact name. So mean, right? And let's check medium, right? Mean, and of course max, right? Yeah. Okay. So I could do round, of course. So 37. So there was a month where it's 37, only 37 foreign tourists came. There's a month where it's 2,300, right? Okay, all right. Let's describe this Let's do some description, right? Describe. So numeric column stats, right? Let's do that at once. Okay, so we can now 72 entries, so nothing's missing. That's good. That's good to know. We know, of course, year, mean, that does not mean anything. But with some of these things, we know standard deviation, minimum. So these are quartiles. So median value will be this, right in middle. Well, obviously, if you have single people have the least number of units, because of course family or a group, right, a tourist group, of course, will be dominating, right? So singles are by in disadvantage in terms of pure numbers, right? So again, so we have some basic data. Let's do this here. Let's do again df describe again O, right? Oh, I'm sorry, typo, right? I always sort of forget. Describe, includo, sorry, includo, right, include. right? So for months only, since that is the only string object column, right? So again, let's refresh our memory to see. I made a new code. What kind of info it is, right? So this shows that these are object and these are all integers, right? Of course, these are whole numbers, right? They look like we have commas, right, in stats, but here we have just the pure numbers. Okay, that's good enough. All right, so far so good, right? So we could save this again. I could save it as Excel, for example, right? I could decide to save it, right? But let's learn some commands. We could do df, for example. I could do df location, let's say 40 to 45, right? Yeah. So see, this gets you this is numeric index. Well, complicating things is why Pandas is complicated, right? Is that we have also we could use also string index here. They overlap, right? So here I will do so will happen df, let's say lock, right? This is one of the most common ways of getting, so this is confusing. So this is string based index, right? So let's see what happens. Here it will be exactly the same. Here it matches, but where it will not match, right? 40, 40, right? Oh, actually that, you see, actually it does. You see, there's difference. So 45 is included here, right? That's very interesting. So there's a slight difference, right? So this is one of the biggest confusion. So again, so iloc is numeric. So in middle, right? So this is lookup. This is numeric row lookup. No matter what the index, the real index looks like, right? So that's kind of a little bit confusing. So let's clear this up again. So let me clear it up. I'll do def index equals df months, right? So now let's check. Yeah. So now our months is the index, right? This is our new index. So what will happen now? Now I could do, for example, df lock, right? Let's say mice, which is May, right? So let's check that. You see, I have all my Mays, right? So that's kind of neat, right? Also, if I didn't have index, right? If I didn't have index, so otherwise, if I do something iloc, right? Let's say do say 2 to 7, for example. This will give me third to fifth row, right? Right? Third to fifth row of year 14, of course, right? So this is numeric again numeric index, but even though our main index is now string, right? So this is probably one of the hardest, the trickiest part. Again, you can use lock and you can use iloc, right? So lock is the actual index, right? And if you want more than 1 month, right? Well, let's say you want more than 1 month, okay? Well, we have 2 ways of doing it, right? We have index already, so we could do this. So df lock, we could do this. We need to make another list, right? And I'll say let's say mice. And what is it? Unis? Yeah, Unis in Latvian. Unis again, so need exact match, and maybe Julis, right? Julis, that's July, of course, right? Julis. Let's see if it works, right? And it's fake months, no months, fake months, right? Let's see. Do we have any errors? Let's see. This shouldn't be there shouldn't be an error. Let's check. Well, there is a key error. Right, fake months, not an index. Okay, so there's no such months, so I do need to get rid of it actually. Right, so let's see that. And we have May, June, and July. Again, so we picked up everything. We have an alternative way of doing it. Let's say we have an index, but we want to have by year. Okay, of course, we could create an index out of the year. That would be one way of doing it. But the other way of doing it would be simply, let's say year 2019. Okay, so I'll call it do 219. Right, I'll save it. So df year equals 2019, right? Let's do that. And I'll show everything. And there is my year 2019, right? So easy way of filtering. So we can filter. We can filter by conditions inside. Okay, so we could do this. Let's do something more complex. We want to see months which had a big family, or no, pupils, right? Let's check pupils, and can notice for some reason they like to go out in May, right? Not in summer, so May is very popular. But let's check these months. So let's do something like this. Let's do a double filter. So pupils, big pupils, right? Big pupils, right? Let's call something silly like this. And so DF, and this will be a multi-filter. So I'll do this. DF, let's say year over 2000, say 15, right? We exclude 14 for some reason, I don't know, or 15, right? And DF pupils, right? This could be pick up pupils over 1000, for example, right? So notice the syntax. We use bit operator instead of usual and there's a reason for it. Actually, again, this is one of those things which make life complicated, but actually it's not that bad. Let's check big pupils. I expect very few months. So May, September, May, June. Okay, June in 2018. September, October, May, September, October. Again, so this is the good old days 2019. Unfortunately, the tourism board has not provided information on 2020. If you find it, it would be great. I'll be very thankful if you find the newer information, but the Open Data Portal does not have it. Maybe I should call up the tourism board, but again, I don't live in CESIS, so again, maybe I should call some other different cities, but this is really interesting, right? So I wonder what happened in these last few years, right? So we have data, right? So filtering by multiple conditions. So filter by multiple conditions, right? So let's check this part here. So this is actually a field. So here, okay, it's Control Z. Sorry about that. So so this is actually this is a Boolean series. Let's check. You see, false, 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 true. So it basically, so instead of doing this, of course, you could pass this. You could give a list of some sort of Boolean values as long as they are the same size. So theoretically, so we could say the filter separately. Okay, so let's get maybe we know how to check by rows. How about only get a foreign Latvian group? How would we do that? Well, compare groups, right? Groups, right? So let's do this. So groups will be DF, right? And we get two columns. So again, Latvian group, right? And foreign group, right? I hope I made it correct. If I make typo, well, let's check. I'll do head because it's a small one, right? Yeah, it worked, okay? And notice I switched them around because, well, in my query, right, I made the query instead of sorting, right, I made the query reverse, right? So that's fine. I can rearrange. So groups data frame has two columns in a different order from original DF, right? So we have ways of working with this group on different checking of these conditions. Again, notice I can use a larger or lesser. I can use something, you know, maybe big pupil. I can do less than after 18, right? No, Control Z, right? I can change the sign, of course, right? I mean, this is or large equal, right? So and then I need to use parentheses, right? It's a little bit tricky, but it works quite nice if we need multiple filters, right? So single filter, right? This is multiple filters. Okay, let's make some new columns. So I'll call Control Z. Let's make this, right? So make groups combined. So df all groups. Let's make a new column, all groups. I'll call it all groups, and it will be, as you imagine, df foreign group plus df Latvian group, right? Let's check, and now we'll see df head again. So now notice there's a new column. So creating a new column, right? And we can see all groups. Okay, so looking pretty good, right? We have all groups. We could also have a plot by some number. Again, we have year, right? So let's go again. Let's check our year 2015. It's curious. Do you have 2015? Where do we have it? Oh, 2019. Right? Do we have it still? Oh, it's here. You see, notice it's not copied directly, right? So again, we'll do it. Again, we can use pupil, but let's plot it. So let's plot this thing and see what happened in the year 2019. So plot. If I do this without anything, this will print everything. This will plot all numeric columns versus index, right? Let's see if that happens. Yeah, it worked, right? January up to November, right? You can see these trends. So this is very quick way of plotting. It's using Matplotlib underneath, right? That's a good start. But we maybe only we want maybe only group singles and couples, for example, right? So how do I do that? Well, easy. And also, well, I have index, so that helps, right? That's easy, right? Because I have index, by automatically it's index. But I want to do maybe something months, right? I could pass something else, right? I could pass this as a value, right? I could do this. So I could do dfd 2019 plot, and let's do y equals let's say single and couple, right? Right, and so you can see nicely. Okay, if I want some other type of graph, sure, no problem. Quick and dirty. Type is bar, right? I hope it works. And I forget now. Let's check. Type. Let's see. Plot, I believe. Let's see. Pandas plot type. I forget now. So we check our documentation. Plot types. Okay, bar. Kind, because type is okay. So kind. Let's add this documentation to you so you can check, right? Again, Pandas has, since Pandas is so huge, you'll definitely need to consult documentation. And meanwhile, while we'll plot it. Yeah, so we have bar chart, okay? And let's do some more plots. You can do scatter. I believe scatter is available. Bar scatter. Yeah, we can do hack scatter. So we can do that. And you can explore some more, right? Scatter, right? And why doesn't work? Scatter plots, but let's see. X column. Okay, so we can do single versus let's see, what could we do? I guess so we need to do X is months, right? Let's check that. Same size. Well, X is the same size, so I guess I need to do single, right? So single or couple or family, right? Yeah, it worked, right? So yes, we need to have same size. So it's a little bit trickier. So this scatter plots are a little bit trickier, right? So again, on the right, I click all these months, right? So you need, of course, again, you can see how it worked throughout the year, right? These are the months. Again, so you can see more of these plots here, all different visualizations. So we're just trying to get a feel for this, right? So let's see, we are doing well. And we have like 10 more minutes to check some more options we can do. So we can visualize. What else can we do? Right, we can save, of course, all this. We can sort values, right? Let's save by most, good idea. Let's save by most family visits. Why not, right? So, and the question is now, sorted family, right, will be df sort values. Come on, let's wake up. Picking up. Okay, sort. Come on, sort values, and we need to check by what columns, and maybe we can add tie breaks. So let's do by family, right? On type ascending or not. Let's check. Sorted family head, right? Right, so it's descending, right? So we maybe want to move this into a new code, and let's do this type. Let's see what is the offer. Okay, let's read it. Axis, kind, in place, ignore index, and descending. What was it called? Key. Let's check. Ascending, right? Ascending, it's true, but we want descending. So ascending false. Ascending, yeah, equals false. Yeah, so from the top, right? Of course, like we have done head, right? So, oh no, yes. So let's see, family. So July of 2017 was the biggest family, you know, when it is most popular for families, right? So again, August of 2019 was good, apparently, and July of 2016. So very interesting. So some months are more, again, the data is more common, right? So again, hope this is of interesting. So we could use this. I create a new data frame. I create a new data frame, right here. I could have also overwritten the old df, right, as well, right? So that is, or use in place. There's also in place option, right? So that's another thing we could have done. So we can now sort, and well, we'll get to grouping afterwards, right? So we can sort. We learned that. I'll delete these. Because these are, we can sort by multiple values. Do we have any tie breaks? Yes. Okay. So let's break a tie break here. So we'll use in cases we'll sort by year, but we'll sort by year and then by, let's do all groups, for example, right? Let's do that. So multiple sort, multiple sort, right, will be what? Df sort values by equals, let's say, year first, right? And then, do we have it here? Year, yeah, we do. And then, so we need to have a list year and then all groups like this. Okay, and again, so then we can say, okay, ascending, maybe true and false, right? So so tie breaks, we have tie breaks now, we have now tie breaks, right? So second is going to be a tie break, so we're going to year is going to be ascending, and then we are going to tie break with this from the largest one. Let's see what happens. So it will be kind of interesting, maybe not very practical here, but still let's do first 13, right, or 15. Let's see if you can trust me here. Right, so we started with the year 2014, but we used all groups as a tiebreaker. So for each year, we start with the most productive year for group visits. So here we have 2014, and we look at the year. So we go up to new year 15, right? Again, the most productive for groups is June in this case. So again, so this is a way to sort by multiple keys, right? So sorting by multiple columns, right? Sorting by multiple columns, right? With different ascending parameters, right? Okay, right. So let's say we decide that there was a systematic error, right? And I can fix it, right? So if we have a year, all the years, the singles maybe are underrepresented, right? Let's check again our here, so df, I'll go back to this part here, right? Let's say singles are represented, but let's say this, so only if it's under 20, we need to add 10 more people, right? So let's try this. So those months, so add singles, right? So let's try this. df let's see, we want to add this to add singles, but let's do this. We can separate. So df over df single less than 20. We decide to add something extra, plus equal 10. So for all single cells in single column that have value less than 20, we add 10. Okay, maybe again, so this will be in place, so let's check. So this means that this should go up 10, this should go up 10, right? And the rest will not go up 10, right? So again, let's do it to 10 so you can see. And yeah, otherwise this probably nothing else will change. Okay, let's check. Let's check. Right. Oh, did I make a mistake? Let's see. This apparently equals where did we make a mistake? Is this actually, I know what the problem is. We don't have a it's an integer. This is an integer. Let's see. So let's first check our syntax here. Okay, that worked. These are only these 4 months. Okay, that worked fine. So why did we didn't work? We don't want to add plus 10 to everything. Yes, correct. We don't want. So the problem was this. I tried to. You see, I was really careless here. I tried to add to all the rows for these 4. So that's even for January. So what we have to do is select the specific months, right? So let's do single, right? Let's do that. That should be. Yeah, okay. It's warning me that I'm doing this indexation. There's some other ways of doing it, but so what happened is it didn't work. Plus equal. Let's see. It should have worked. Single less than 20. It didn't work. Right. Copy. So we need to probably do this indexer. Probably need to do this indexer. Maybe have a copy first, right? So I tried to do this. So it actually did not work. So we would need to do the separate rows, right? Let's see. Can we actually do this in a separate shape? Let's do this. Few singles. Let's do it in multiple ways. Right? Few singles like this. Yeah. And so can I add it? So few singles. And let's do single plus equal 10, or let's say 15, you know, I don't know, 20. Still doesn't work. Yeah, it still doesn't work. Oh no, it works. Now it works. Now it works. The question is now, what do you think? Now that important question, will it work? Will this data be reflected? It's a copy of slice from the original data. Is it original going to be changed? So that's a very important part here. And that's where again Pandas gets tricky. Is so df, let's check head Yeah, it's still original, so it's not changed here. So I would need some way of fixing this, of finding these particular values on. So my copy has it, but the original is still unchanged, which is good, of course, right? So if I want to change some values, I need to actually go into documentation and look more into this filtering. Okay, so let's see. Let's delete some of these Titanic. This is also a very interesting data set, but unfortunately I don't have it available here. You need to find it yourself. And now let's see this, all of this sort, write some data, and we can finish this again. Right. Let's see, yeah, where is our data? Oh, there we're here, right? Let's delete all of this. Come on. Let's see, delete cells. I think tools, edit, delete cells. Yeah, okay. Let's do some more deletions, right? Since we have some extra data here, right? I'll go to the end, so I can go like this, and I can go delete these extra cells, right? So let's check this. So we don't have it. Okay, yeah. Edit, delete cells. Okay, that's better. All right. So let's plot. So there's some advanced stuff. I would like to do some grouping to do. Right. I would like to do some more to do show grouping and aggregations. But hopefully you got a good idea how this Panda works. And let's again. So again, if I want to, right, I want to save it. Right. I can do basically df to Excel, for example. Right. Excel on say my thesis tourism XLX, right? I'm done working on. So now if I've done working, I can do now save it here. I can download, of course this is because Google Colab, right? I'll download so I have it in my own machine, right? And I can open up and let's see what I have. Yeah, there it is, right? Months, single, right? You see all the data, all groups, all of the columns are available, all the data is available in Excel if you need to, right? If you need to. Okay, so thank you very much, and we'll continue with some more operations after in our live session.